Hello everyone, in this video tutorial, we will create a Retrieval-Augmented Generation Streamlit application using DeepSeek through Ollama. So assessing the DeepSeek model using Ollama is preferred because Ollama allows us to run DeepSeek model locally on our machine, and also Ollama avoids sending sensitive data to external server. And to if you want to run DeepSeek using Ollama, you don't need an API. Like if you want to use Gemini model or any OpenAI model, you require an API. But if you want to use DeepSeek using Ollama, you don't need an API. So running DeepSeek using Ollama is absolutely free. You just need to download the DeepSeek model from Ollama, and you can download it freely as well. After you download the DeepSeek model from Ollama, you can use DeepSeek model offline as well, and it's totally free. You can just need to install Ollama and download the DeepSeek model from Ollama. So let's get started with this. So here you can see that I have just created a Streamlit application. So let me just first give you a demo of the Streamlit application that I have created. So like here, user can upload a PDF file. I have already uploaded a contract over here in the which is in the PDF form. And now what I am asking is, what is the total amount mentioned in the contract? Okay. So the total amount mentioned in the contract is 150 USD. So let me just show you the contract if this is right. So you can see that the total amount mentioned in the contract is 150 USD. So in the same way, I can ask more questions from this PDF as well. So as I go forward and build this application from scratch, we will be asking multiple questions from the PDFs that we will upload. So this is a quick demo of the application that we will be building in this tutorial. So we will be creating a Retrieval-Augmented Generation Streamlit app using DeepSeek. In this Streamlit app, the user can upload any PDF file, and then they can ask questions from that PDF file as well. So that is a quick demo. So let's get started with this, and let's start build this app from scratch. So here you can see that I am in my Streamlit in my PyCharm community edition. Like you can see, I am in the PyCharm community edition. So in the previous tutorial, as you know that we have created a Streamlit chatbot application using DeepSeek through Ollama. And in this tutorial, we are creating a Retrieval-Augmented Generation Streamlit application using DeepSeek through Ollama. So I'm using the same project, and so now you can see that previously in the previous project I've used these three libraries. So for this current project, for this Retrieval-Augmented Generation project, I've added two more libraries, which is LangChain community and PDF Plumber. Okay, so that we can load all. So we require this PDF Plumber so that we can load all the content from the PDF file that we have uploaded. Okay, so I have already installed these two packages as well. Okay, so now I will just create another .py file by the name app-track.py. Okay, so let's start this now. So in the step number 1, we will import all the required libraries. So I will just import Streamlit as st. Then I will just import PDF Plumber loader so that I can load all the content from the PDF file, or you can see you want to read the PDF file. So I will just write from LangChain community dot document loaders import PDF Plumber loader. Then I will just write from LangChain text splitters. I will be using recursive character text splitter. So we have like simple character text splitter as well, and we have a recursive character text splitter. So recursive character text splitter makes sure that the context of the text when it splits remains if you simple characters text splitter, it will not keep in mind that the context of the text would remain there, but recursive characters text splitter make sure that the context of the text should not be disturbed. Okay, then we have from LangChain code dot vector stores. So after extracting the text from the PDF, we cannot pass that text directly to the large language model. We just because we split the text into smaller chunks because um, each large language model has a input token limit. So if we have a very large PDF and if we pass the text directly to the large language model, it might exceed the token limit. So we basically convert the text into smaller text chunks, and then we, after converting the text into smaller text chunks using recursive character text builder, then we create embeddings for each of the text chunk. And after connecting embeddings for each of the text chunks, then we uh, save that text into a vector database. So first I will just import the embedding model. So I will just write from LangChain dash Ollama. I will just use Ollama embeddings. So after splitting the text into smaller text chunk, we will create embeddings for each of the text chunk. Okay. Then going ahead, we will save those embeddings into a vector database. Okay. And I will be using, like previously I used chat Ollama model. Here I will not use the chat Ollama model. I will use the Ollama LLM. Okay. So this is basically a raw text model. And lastly, I will just import chat prompt template. Okay. So now I will just define a prompt template first. So I will just write prompt template. And I will just write, you are a helpful assistant. Use the provided context to answer the query. If you don't know, answer, state that you don't know, be concise and factual. Okay. So we'll just pass the query as user query. And here we have the context as document context. And here we will have the answer. So now in the Streamlit app, when the user uploads a PDF, we want to save that PDF in our local directory as well. So we'll just create a directory by the name document store, and we will also contain a subdirectory inside this as well, which will be PDFs. So we'll save all the PDFs inside this PDFs directory. So okay. So save uploaded PDFs will be here. So we'll just define the PDF storage path over here. This will be document store, then PDFs. Okay. So now in next we'll also define the embedding model. So we'll just define our embedding model, which will be Ollama embeddings, and we will be using the DeepSeek model that we downloaded. Okay, so we have downloaded 1.5 billion parameters model, and after converting that text into smaller text chunks and creating embeddings for those text chunks, then we'll save those embeddings, which are vectors, in our vector database or in our vector store. So save embeddings. In vector DB, vector database. So we will just define document vector db is equal to in-memory vector store and embedding model. Then we will just initialize our language model over here, and we will be using Ollama LM, and here the model will be DeepSeek R1, and we'll set the temperature as 0.9. So now we'll create a few helper functions now. So let's create some helper functions. First, we need to save the uploaded file. So we'll just create the function save uploaded file. So we'll just write uploaded file. And here I will just define the file path is equal to PDF storage path plus uploaded file dot name. Okay. So we'll save the uploaded file into this variable uploaded file dot name, which we'll define later on. And I will just write with open file path. So we'll just write the file into this file path. File dot write uploaded file dot get buffer, and this will return the file path. Now next we will load PDF documents. So we'll just write file path is loader. So this will load the PDF file or read the content from the PDF file. So let's write file path return loader. Okay. And define now the small after reading the PDF or loading the text from the PDF file, we need to split that text into smaller text chunks. So I will be using recursive character text splitter, and we'll create a text chunk size of maximum 1000 characters. Like each chunk will have maximum of 1000 characters, and there will be an overlap of 200 characters. And this will return splitter dot split dash documents, and here we'll just pass documents. Now we'll just convert the text. Now we'll convert the text chunks into embeddings. Okay. Okay. And then we will save those embeddings into a vector store. Okay. Now when the user asks a question, then we will find the related data to that query that the user has asked. So this will return similarity search. Okay, so now we will create a last function which is generate answer. So the user asks a query, and we'll just write context is equal to and from okay. And now I will just write prompt here as chat prompt template I will be using, and from that template we'll define the prompt template over here. And here we will just write response chain is equal to prompt. And here we will just write and here I will just write dot invoke. Okay. So now we'll just create a Streamlit UI. Okay, so I will just write st.title. We'll create a Retrieval-Augmented Generation application, and we'll just add a caption PDF, and or we can just create a model. And now we'll just write uploaded PDF is equal to st.file-uploader, and I will just write upload a PDF document, and the type of the document will be PDF. Okay, and I will just write if uploaded PDF, then I will just write file-path is equal to save uploaded file, and here I will just pass the uploaded PDF file. Then we have raw-docs is equal to load PDF documents. Okay, then we'll just after reading the PDF, then we will split the text into smaller text chunk, and I will just write chunk documents raw-docs, and then you will create embeddings for each of the text chunk, and we'll save those embeddings into a vector store. So after this process completes, then we can just play a message document process successful. Okay. Then we can just create a user query over here. Let's chat dash input, and we can just write ask a question about the document. And if the user asks a question, then we'll just write chat dash message. Okay. And here I will just write and we will also create a spinner. It will be st.spinner. Analyzing documents. Okay. And we'll just write related docs is equal to find. I will just call this function file related documents, and here I will just pass the user query, and then lastly we'll call the generate answer function, where I will just pass the user query and related documents so that it will LLM will generate a natural response from there, and we can just write with st.jet-message, and we can just write assistant. We can just add an avatar here. So this reference that this is response is generated from an AI assistant, and here we can serve once. So we have just created a Streamlit app. So now I will just run this Streamlit app over here. So I will just write Streamlit run app -var. So now let's test our Streamlit application. So now I will just upload a PDF over here. And now it will, now you can see that it's currently running. So it will be analyzing document. Then we will ask a question after it process the document successfully. And then we will be able to ask the question. It will take few seconds. So let's wait. So meanwhile, it processing the document, as I told you that we will be saving the uploaded PDF over here in the directory. So you can see that we are able to save the PDF over here, like this contract-moving.pdf over here. Okay. So now currently it's processing. So let's wait for this processing to get finished. So now you can see that document processed successfully. So now we can ask the question, what is the deadline mentioned in the contract? So now you can see that it has been processing. So let's wait and see how it generates a response. So this will take few seconds, and let's wait for a few seconds before we get the response. So now you can see that we have got the response. What is the deadline mentioned in the contract? So now you can see the final video must be delivered and published no later than 14 days after the agreed deadline. Okay. So here you can see that final video must be delivered and published no later than 14 days after the agreed deadline. So we can ask more questions from this PDF as well, like what is the total amount mentioned in the contract, what is the effective date of the contract. So you can upload any PDF and ask questions from that PDF, and you can in currently we can upload one PDF, but you can just modify this code and you can upload multiple PDFs as well. So in this tutorial, we have created a Streamlit Retrieval-Augmented Generation application using DeepSeek through Ollama. So where we can upload our PDF file and we can ask questions from those PDF files. So that's all from this tutorial. I hope you have learned something from this tutorial. Thank you for watching.